6. The picture shows Marco listening to music from a speaker in an adjoining room. Look at how these waves travel. Once again, if you know the definitions and you know the pictures or how the wave behavior looks, it's going to be easy to tell that this is actually showing diffraction. So now, why can Marco hear the music even though he is not in the same room as the speaker? A, the sound is being reflected around the corners. No, it's not being reflected. B, the sound is being refracted around the corners. No, it's not being refracted. It's not bending as it goes through a different medium. C, the sound is being absorbed. If the sound was being absorbed, Marco would not be able to hear the sound. Look at D. The sound is being diffracted around the corners of the doorway. So let's look at this. As it enters and it goes through that doorway, look at how these sound waves begin to travel and they begin to bend. And that's what causes Marco to be able to hear these waves through the wave property of diffraction, wave behavior diffraction. 7. Sarah has a red jacket. Which of the following models shows how Sarah's jacket reflects and or absorbs light? Remember, if her jacket is red, that is what's being reflected back to our eyes. And then all the other colors are being absorbed. So let's see which one shows that. A shows all three colors being reflected back to our eyes, so it's not that. Look at B. B shows that red is being absorbed, but green and blue are being reflected back to our eyes. That means that would make us see green and blue and not red. Look at C. Green and blue are being absorbed, but the red is being reflected back to our eyes. So our answer choice is C. And then D shows that all three of these waves are being absorbed, and that's not true because nothing is being reflected back to our eyes. So our answer choice is C. 8. Malika looks at a beetle through a magnifying glass. Why does the beetle appear larger under the magnifying glass? So once again, as you look through that magnifying glass, that light wave is traveling from a gas to or gas through a solid. So that means it's going from one medium to the next. And if you know your definitions, you understand that it's actually being refracted. So let's look at A. Light that passes through the magnifying glass is refracted. Yes, because that light wave is actually being bent as it travels from a gas to a solid. So let's look at B. Light that passes through the magnifying glass is reflected. No, that means it's bouncing off. C. Light is absorbed by the magnifying glass. No. And then D. Light is doubled inside the magnifying glass, and that's a nonsensical answer, so we can cross that out. 9. The picture below shows a duck swimming in a pond. Why does there appear to be another duck head in the water? Well, the same thing when you look in a mirror. When you look in a mirror, the light waves are actually being reflected back to you. So why is there another duck head that appears in the water? Because the water is actually reflecting that light wave back. So let's look at A. The water in the pond reflects the light from the sun, making a mirror image. So our answer choice is A, because it is being reflected and it does make a mirror image. B. The molecules in the atmosphere refract the light, splitting it into two images. That means it's saying that it bends, and refraction does not do that, and it does not produce a second mirrored image. C. The duct scatters the light, making hundreds of tiny refractions that collect into an image. No. And then D. The bottom of the pond absorbs the light, then projects it towards the surface as an image. And that's definitely not happening. That means that the light is going all the way to the bottom of the pond and then coming back up and showing as a mirror. 10. What happens when light is refracted? So if you understand the definition of refraction, and you understand that refraction looks like this. A wave bends as it travels through a different medium. So A says it moves faster. So it won't be A because depending, it can move faster or slower depending upon the medium it travels through. B, it releases heat. Absolutely not. C, it becomes invisible. That's not true. And then D, it changes direction. So if you look at it, refraction causes that light waves to come in at one angle and then change the direction as it bends slightly into another angle. Number 11, what is the difference between a reflected and a diffracted sound wave? So remember, I like to draw it because reflected does that. Diffracted means that it's going and is actually bending as it goes through an opening or go around something. So I'm just going to draw this and I'm going to show it actually spreading out like that. And this is going to help us answer the question. A, a reflected sound wave is absorbed by the medium. A diffracted sound wave changes direction as it passes through an opening. So reflected sound wave is definitely not being absorbed. B, a diffracted sound wave bounces back to the place of origin. That's saying that it's actually being reflected. So it can't be that. C, a reflected sound wave bounces back to the place of origin, which is true. A diffracted sound wave changes direction as it passes through an opening. So that right there is true as well. Then look at D. So our answer choice is C, but look at D. A diffracted sound wave bounces back to the place of origin. It does not bounce back. So our answer choice is C.